Here we're having a question that asks us to draw the final product of the reaction where we are seeing alkyl dihalide reacting with a strong base, in this case potassium hydride, so that gives H-, and then we are asked to provide the product. Now notice that we are using two equivalents of the base, and that indicates a two-step process. So the first step is that the base is going to abstract one of these two hydrogens. So in this case, I will use the base to abstract this hydrogen. At the same time, the carbon-hydrogen bond will break and the electrons will flow here to form a double bond. And then at the same time, you're going to kick out one of the halides, so the iodine, for example, and you end up with this as a product, where now we have a double bond here. So that's just using one equivalent of the base. Then we're going to repeat the same process, but now we're going to use a second equivalent of the base, so potassium hydride again. And this time round, the hydride will abstract the remaining hydrogen, and then the electrons between carbon and hydrogen will flow to form a triple bond, while at the same time you kick out the bromide and you end up with a triple bond at that position. Now that's not the best way to write triple bonds, because we know that triple bonds are sp hybridized, so this needs to be sp hybridized. And we know that sp hybridized means that the bond angle is 180 degrees, and we can see clearly that's not 180 degrees, and therefore we have to redraw the structure so that now these two sp carbons are linear because they're sp hybridized, and that will be the product.